Find the mistake in the following proof. Theorem: for all sets A and B, A complement union B complement is a subset of A union B all complement. The proof: suppose A and B are any sets and X is an element of A complement union B complement. Now I'll pause here. Let me just say I haven't seen this proof yet. And so my goal is to run into this mistake with you, with the viewer here. Now the start of this proof looks perfect. If we want to prove that this set is a subset of this set, then we need to start with an arbitrary element of the first set, which is exactly what we do. Now, we want to unpack the last operation done in this expression, which is the union, and that's what this author does. Then X is an element of A complement, or X is an element of B complement by definition of union. That's correct. So the proof is correct up to this point. It follows that X is not an element of A, or X is not an element of B by definition of complement. That's true, that if X is an element of A complement, then that means X is not an A, and since X is an element of B complement, then that means that X is not an element of B. That's the definition. And so X is not an element of A union B. Let's pause here. Now let's think about what the author did here. The author thought to themselves that we can replace this or with the union symbol, but that's not how this works. The union symbol says that if you have an element that's in one set, or you have that element in another set, then that means that element is in the union of those sets. But to say that X is not an element of A is not the same thing as saying that X is an element of a set. You can only convert these OR operations into the union if you know that X is an element of one set or the other set. But that's not what we know here. What we know here is that X is not an element of A, or X is not an element of B. So the reason why this doesn't work is because this is not the definition of union. If you look up the definition of union, you will not find any of these symbols. These symbols are not in the definition of union. And so the author of this proof is trying to take a definition that only applies when X is an element of A or X is an element of B. We're trying to take that definition and apply it to something where it's not supposed to be applied. The definition of union is not meant for this symbol here because it's not part of the definition of union. And so far, the ultimate flaw of this proof is the conclusion that X is not an element of A union B by the definition of union. That is not the definition of union. The next line says, thus X is an element of A union B all complement. Now that would follow from the previous line if the previous line were true, and hence this would be true if what I underlined here was also true, but what I underlined is not true, and that's because of the definition of union. The definition of union does not have this symbol in it. Thanks everyone, and I'll see you in the next video.